Okay. So yesterday we understood about the just a second. Yesterday, I think we understood about the Databricks deployment architecture, right? So this is the architecture irrespective of the cloud, and I've explained about the architecture with respect to Azure, right? Deployment architecture, I can say, backend who is maintaining what. So that's what I was trying to explain here. Okay. Now today, we'll try to create actually Azure account, and we'll start. Or else tomorrow we can create that one. Okay. Today I'll try to explain about the generic concept, that is the Delta Lake concept and the DB utility commands. And if possible, like tomorrow or day after tomorrow, we'll try to create the Azure account and start working the same same topics we'll try to discuss in the Azure account as well. I mean, there is no much difference when you execute here and when you execute in the Azure, but we'll try to see that slight difference is there actually, that we'll try to understand. Okay. Huh. The next topic is actually, I told you Databricks is also acting as a data warehouse. Okay. See, when I started the Databricks course, I told you only one point here. Databricks will act as a processing engine, right? So we can do only transformations with the Databricks, right? So we can write these Spark commands and whatever the data we extract from the different sources, and we take the data and we apply transformations and we load them into the target tables. That is what I could have explained it. Okay, now I'm telling that I'm just extending that topic a little bit here. So along with the transformations, Databricks can also act as a data warehouse. So how your regular data warehouses which are available in the market, right? Same way it also behaves. Okay, like your Snowflake, Teradata, Postgres, how these databases are behaving, right? In the same way, Databricks also can act. Okay. So how it is acting, Shiva? We don't know that. Yesterday I've shown you right already. So this is what I was telling you. This is what I was telling you yesterday. So left side you can see the databases and the schemas. If I expand, not demo DB, if I refresh this one, I've dropped the demo DB. I don't know why it is showing up again. Let me let me close everything. Just a second. Yeah, if I click on this one, see, I can see test DB here, and I can see test schema that I've created yesterday. Okay, currently I haven't created any tables and any volumes here. That I'll try to discuss today. Um, what I wanted to say here is, after processing, we'll try to store our data in the data warehouse here. That data warehouse, we call it as a Unity catalog here. Unity catalog. Okay, Unity catalog. With the help of this one only, we will try to store the data. Okay, Shiva, you're saying that it will act as a data warehouse, right? So backend, how it stores the data actually? If you take Oracle, if you take SQL Server, how those databases actually store the data in the backend in the form of files, right? But you cannot able to see the files actually. You cannot able to access the files. But here you can access the files. Okay, how it stores, in the backend, in the Unity catalog, in the data warehouse, it stores the data in the form of delta files. Delta files. What is this delta file, Shiva? We never heard about this one actually. Can you explain a little bit about that one? Yes, that is what I'm going to discuss today. Okay, so how we have files, right? CSV, JSON, XML, Parquet, sequence file, Avro, ORC, how we have different kinds of files are there, right? In the same way, we also have delta file format. Delta file format. Okay, so that is what I'm going to discuss. Siva, like who created this delta file format? What is the extension of this file format actually? For CSV, I know All the CSV files extended with .csv. All the JSON files extension is actually .json. All the Parquet files .parquet, ORC. But what is the extension of these Delta files? What exactly this one? The definition of these Delta files here. That is what I'm going to discuss. So Delta file format is an open source file format, guys, actually. So it is complete. Just a second. Let me erase these things. Just a second. Ah. So the website of the Delta is actually this one, delta.io. Okay. See, this is purely created by the Linux Foundation, which is open source community, I can say. So these guys are saying Delta Lake is an independent open source project. This is open source file format, I can say. Okay, so how it stores the data, that I'm going to talk bit later. Okay, but first I'll try to talk about the Delta Lake. Delta Lake or Delta file format, both are same only. Delta Lake or Delta file format, both represent same. Okay, Delta Lake or Delta file format is an independent open source project. It is open source project. It is not like belongs to any of the company. And that's what they are trying to say. It is not controlled by any of these any single company. To emphasize this, we joined the Delta Lake project in 2019. They started like doing the research from 2019, 6 years back, 6, 7 years back only. Okay, which is a sub project of the Linux Foundation project. This is one among the like Linux was doing the research, right? So this is one among them actually. Okay. So what is the advantage of this one? What is happening here? Can you let us know here? So they are saying that Delta Lake is an open source storage framework. See, it's a framework actually in the backend. It's a framework that enables building a format agnostic lakehouse architecture. I'm going to talk about what is this lakehouse with compute engine including Spark, PrestoDB, Flink, Trino, Hive, Snowflake. All these people started using this Delta Lake, guys. Now this has become the hot cake in the market. This file format, I can say. Okay, everybody started using this one. See, all these like famous, all these guys are actually famous data warehousing guys, right? They started using all these things actually, Delta Lake in the backend file format. So what are all the different features of this Delta Lake? Okay, that is what I'm going to discuss now. So currently Delta Lake 4.0 is running, guys, actually. Even in the Databricks also backend they're running 4.0 only. They're using 4.0 only. Delta Lake 2.0, 1.0, 1.0, 2.0, 3.0. The latest one is actually 4.0. Okay. Okay. So what are all the features of this Delta Lake, Shiva? Okay. The first one is ACID transactions. So you guys know what is this ACID transactions, right? This is the basic feature of the any of the database. Oracle follows this ACID transactions. SQL Server follows this one. Postgres follows this. Every database, if you want to say that is a database, then it has to satisfy this ACID transactions. Okay, so I'm not going to discuss much about these ACID transactions here. I want you to explore this one and try to come up with some conclusions tomorrow. Okay, what exactly mean by this ACID transactions? Because this is one of the interview question actually. Atomicity, consistency, isolation, D is durability. The full form of ACID is atomicity, consistency, isolation, durability. That is the full form. So what exactly meant by this atomicity and consistency, isolation, and durability? That you guys, I want you to do that research. Okay. Huh. So Delta Lake actually uh, like follows the ACID transactions. I mean, What I can say is how your databases are actually following, right? How your databases are behaving, right? In the same way, Delta Lake also or Delta file format also follows. Okay. Scalable metadata. I'm going to discuss this one in some time. Okay. So I'll talk about this one. Um, time travel. Time travel. This is very important feature of the Delta Lake, I can say. Um, Even if something goes wrong in your table, in the backend table level or backend file level, we can still travel back and get your data back. You can restore your data back. That's what the meaning of time travel. This is quite similar to time travel that we have discussed in Snowflake. Okay. And it is open source. Of course, no one is controlling this one. No license is required. No charges, nothing. Okay. And unified batch and streaming. For the batch processing also, we can use the same file format. And even for the streaming process also, we can use the same file format. Both we'll try to discuss in this course. So I told you, right, like in Spark or in Hadoop, for Spark, they used to use actually Parquet file format is the best suitable file format. They used to use that. For streaming, they used to use Avro. See, here we don't have multiple file formats. We have only one file format, that is Delta file format. So which can satisfy both batch processing and the streaming processing. Okay. So schema evolution and schema enforcement, that also I'm going to talk in some time. And audit history, what is happening in the backend when you do some transactions? Some transactions in the sense like when you do update, what happened in the backend? When you do delete operation, what happened in the backend? When you do insert operation, what will happen in the backend? Everything is tracked here. I'll show you that one. Don't worry. Okay. And we can perform DML operations on top of this Delta. How we are doing the DML operations in the database, right? Update, delete, merge. In the same way, we can do that one. Okay. So in order to demonstrate all these features, I wanted to open my okay. I just wanted to open my Databricks trial version here. This is the trial version that I've created yesterday. Okay. So when you create a trial version, I told you you'll get all these options here. So first, what you have to do is you just need to click on this SQL editor and open this one in a new tab so that it opens left side the default databases like workspace system, right? And we have created one database called testdb. Create catalog name. So here database we call it as a catalog. Okay. So under that, I've created a schema called test schema. Okay. So under that, what I need to do is I need to create volumes. What is this volume, Okay. If at all, if I want to play with some data, I need to, if at all, if I want to create some file, I need to have some location, right? I need to store them in some place, right? That is nothing but your volume. So I'm going to I'm going to demonstrate about this volumes concept once again in the Azure Databricks. Once I create the Databricks service in Azure, I'll tell you how exactly they are doing in the backend. For now, you just try to understand this is just a temporary location where we can land our files. Okay. So for that, what we need to do is we just need to click on this test schema. Quite opposite to that one, three dots are there. When you click on that one, you're getting three different options here. Open in Catalog Explorer, copy schema path, and add to favorites. Copy schema path is nothing but it will try to copy the fully qualified name. See, DB dot test schema. Okay. So mostly we use this option and this option only. Add to favorite is nothing but I mean, when you log in, right, it will try to automatically use that particular database and schema name here. Okay, in the workspace. So for now, I'll just try to what I do is I'll just try to open the first option, click on the first option here, and it is opening up in a new tab here. Now, what we need to do is, am I recording the session? Oh, sorry. What we need to do is, here we need to create a volume. So for that, we have an option called create here. Click on that one. So here we are getting multiple options. Oh, model options we are getting. Okay. It was not there previously, but we have that model app. Let me click on this one. Okay, I'll explore that one a bit later. So for now, I'll just try it. I'm focusing on the volume option here. Click on that volume. So what is that volume name that I'm trying to give here is, see here, files are stored in a location managed by Unity Catalog. See, since it is a trial version, backend they could have tied up with one of the cloud provider. It could be with the Azure, or it could be with the AWS, or it could be with the GCP. And they are trying to store the files which we are going to store in the volume in that cloud storage, in the Unity catalog indirectly. Okay, I'll talk about that Unity catalog concept a bit later. Unity catalog is nothing but a data warehouse in Databricks. Okay. Okay. So my volume path is source underscore volume. Something you can give some name here. Okay. I'm just trying to create a managed volume. I don't select the external volume, because if at all, if you're selecting external volume, we need to have cloud in place. Currently, we don't have any cloud, right? I mean, we don't have that Azure or AWS and, in place, right? So that is the reason I'm not selecting this one. So if you're selecting that one, it is expecting actually that location. See here, S3 bucket name external location path, right? So I don't go with that one. I go with the managed volume. Okay, that is completely managed by this Databricks people, I can say. Okay. Now let me click on create here. So I created volume called source volume. See here, you can see folders we can upload in a cloud, Databricks cloud. See, backend where they are storing, that is none of our business. They 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 might be storing it in Azure, they might be storing it in AWS. That's none of our business. Okay, so they are giving actually a uh, path to us, a folder path to us. Okay, where we can create our folders and we can upload our files to that location. Okay, so let me go ahead and create one more volume here, that is target.
Shiva, here external volume default showing S3. Why it's showing S3?
I mean, they're just saying that. Okay, let me show you that one. Or let me create, let me try creating that volume, external volume. See, they're just trying to say that the path, you have to follow like this.
If Azure,
If it is Azure, ABFSS. If it is AWS, S3 colon. That's it.
okay,
So the path may vary depending on the cloud, I can say.
okay,
Okay. So if to answer your question, why they are showing by default S3 path here, they could have tied up with the AWS in the backend.
okay,
That
Yeah,
could be the reason. I mean, I'm just guessing it.
the trial for the trial account you'll get AWS.
AWS, huh? Okay.
Yes.
Yeah.
okay, got it.
Okay. So that is the reason why by default they're showing the S3 path here. Okay. So what I'll do is, let me cancel this one for now. So I created a couple of volumes here. You can start creating folders inside that one. You can start uploading your files into this, and so that backend it stores the data in the cloud, AWS cloud. Okay. Okay. So let me do that one. Source volume, I don't use this one. I mean, I just created like that. Okay. So what I'll do is, I'll start executing my queries here. Uh, where is this one? Okay, Deltalake. Yeah. So this is the notebook that I've created just before your class. Okay. What I've done is, I just created this notebook in my local. I just imported that one into my Databricks environment. So how we have to do that one is, so I told you, right, by default, you'll get these folders. Okay, if I click on this one, by default, you'll get these folders, right? So if at all, if you want to create your own folder here, you can go ahead and create that one. So currently, I'm not going with any of the folder. I'm going with my users uh, because these are my personal ones, right? So I'm going with them. I mean, if you want to go ahead and create a folder here and start like creating a notebook, see, that's up to you. You can do that one, obviously. Okay, nobody will stop you. So for now, I'm just going to my users. In my users, actually, I created notebook called demo. Okay, so this demo DB, I did not create anything. I think just I just executed print hello world. What did I do is I just imported this Delta Lake from my local. So how did I do that one is click on this one file. Guys, remember one thing. Even in the real time also, even in the Azure Databricks also, you'll get exactly same options. The beauty of this trial version is, which they recently started, is all the options almost they're showing up here. Okay, so let me click on this file here. If you have your like Python file or interactive Python notebook file or DBC file in your local, you just need to click on import and it will ask you your local path actually. Or if you know that file, you can directly drag and drop that one here. Or if you know your local path, you just need to click on it will ask you to choose the file from your local path. So currently it is in different path. You need to select that one and you need to click on import so that it will get imported to your respective folder wherever you're importing it. Okay, and start writing the comments, whatever you want. Okay, in real time, we day in, day out, we play with these notebooks only. Okay, we simply write these Spark commands in the notebooks. See, Databricks is just a UI. Ultimately, back and we write everything in Spark only. Everything we write in term, we do transformations in PySpark only. Whatever we like discussed right till last week, that is what we are going to do. That's it. On top of that one, we need to understand some additional concepts here in Databricks. That's it. The heart of the Databricks is PySpark only. I mean, you can use Scala Spark also, of course, and even SQL also you can use. But the default one and mostly used one is actually Python. See, when this is my notebook, right? You can rename this notebook by double clicking on this one. You can see here in the notebook, the default language is Python here. I did not select this one. When you create a notebook, by default it will see. If you want, I can show you that one. Click on this one. New notebook. I'm creating a new notebook here and see by default what is the language it is showing up? Python. So by default, Python it is showing up here. You can write your commands in SQL. You can write your commands in Scala. You can write your commands in R as well. Okay, any of the language you can use. So mostly 90% of the cases, either we use Python or SQL. That's it. Okay. I mean, if you have Scala project, of course, you can go ahead and use that one as well. I'm not saying that we never ever use the Scala. That depends on the project. Okay. R also we can use if you're dealing with the data science related projects. Okay. Now I'm just trying to create a sample data set here, event ID, event name, event date. This is my schema and this is my sample data set actually. I'm just trying to create a data frame on top of that. Guys, I told you, right, in PySpark, we have show command. In Databricks, if you want, you can use show command or you can use display command as well. Okay, display of df also we can use here. Display of df. Okay, this one also we can use. So what is the difference between the show command and see show is showing like this, right? Okay, let me show you. When you write display command, you'll get output in a table format, proper table format. How we get it in a regular traditional databases, right? In the same way we get it actually. And we can copy the column names here. And if at all, if you want to sort the data, you can sort it here. Or if at all, if you want to filter the data, you can filter it here. I can click on here. I can filter the data here. So event ID is one of the one I can filter here. Whatever you want, you can do. Some UI related activities you can do here. That's what I wanted to say here. But if you write same thing show command, right? You'll not get that flexibility actually. Okay, what I do is df dot show command. I'm just writing here. Okay, show is just a PySpark command. You can still go ahead and use that one. Nobody will stop you. But this is display is an advanced command of show command, I can say. Mostly in real time, 90% of the cases or 99% of the cases, we go with the display only. So display of df also we can use, or df dot display also we can use. Many people doesn't know this actually. Dot display. This also we can use. Let me comment this command and let me try to use this here and see you're getting the same output. Df dot display or display of df, both are same only. Same options you're getting here. Clear up to this?
Yes, Shiva.
Okay, moving on. Okay, I have the data in my data frame. Siva, what do you want to do with that data? How do you want to play with that? Yes, that's what I'm doing now. Okay. Uh, Event date and event location. Event coordinate is also there. Okay. Yeah. I'll try to take. Okay. I think yesterday we created this one, right? Event coordinator and all, right? Okay. I was just wondering why did I get all these columns? Yeah. I just deleted that one. No problem. So now I have this data frame data here. And what I wanted to do is I wanted to write this data. I wanted to write this data to my volume path. Volume is just a folder in your local. That's it. Consider for now, understand for now, volume is just a drive. Volume is just a drive. How you have C drive, D drive, F drive in your local, right? In the same way, you can go ahead and create the folders inside this drive. Okay, that is what target volume is our volume name, right? So, volumes are actually part of the child objects of the database. That is the reason why we are able to see the fully qualified path as volume slash database name slash schema name slash your volume name. Always you'll get the hierarchy like this only. Inside that one, I'm trying to create one folder called Parquet data, and I'm trying to store my data into that folder, Parquet data folder. At the end, whatever you mentioned, that it will try to it will treat that as a folder here. Okay. So this is my Parquet data. I'm just simply see what I'm doing here. You know how to save the data. You know how to write the data to the external systems or to the targets, right? So I'm simply taking the data from the DF. I'm using write method here, mode overwrite method. If you have that folder, it will try to overwrite that one. If you already have it. Okay. Format, which format? Parquet format I wanted to write it actually. You know how to write the Parquet format. Dot save of, where do you want to save this data? See, previously, okay, in the older version of the trial account, the Databricks trial account, we used to have DBFS path actually. Now we don't have the DBFS path. If you want, you can mention that DBFS here also, colon slash slash like this. Okay, but I don't want to mention this one. I'll show you like how it looks like. Okay, so I'm just trying to upload my data to this particular folder. Okay, let me write it here and see what is happening here. Demo DB does not exist, right? What is that? Okay, I could have created demo DB. Okay, let me go ahead and create the demo DB. Or otherwise, I have to replace test DB, demo DB with the test DB. I'm just rejecting this one. Instead of demo DB, I'll just try to take here test underscore DB. Okay, I'll just copy this one. Going forward, I have to paste this one right everywhere. That is what I'm going to do. Uh, okay, that's fine. I'm just I copy paste it. Let me execute this command one more time and observe here. So I keep executing these commands and I keep observe the backend things here. So since it is writing, oh, it has written the data. Now let me refresh this. Come on. Meanwhile, let me execute this one also. Instead of demo DB, I'll just try to put it as a test DB here. Now see here, test DB, test schema, and under source volume actually, nothing is there. I'm just trying to write the data to the target volume. That is the reason why. See here, we got the folder name as Parquet data. Okay. See here, this is what we get it right. Even at the time of PySpark Parquet file loading, I told you the same thing, right? We will get one success file and we'll get one committed file, and we'll get based on number of partitions, the Parquet number of Parquet files will be created here in the backend. That is what happening here. Okay. See, I wanted to compare here Parquet file and the Delta file format. That is the reason why first I'm trying to demonstrate the Parquet file format here. See, I got two Parquet files here. Okay, if you want, I can expand this one little bit right side here. See, snappy.parquet. I told you snappy is the compression. That's the default compression in Parquet. You guys know what is this part hyphen 00 00000 means? And you know what is this means? This is the transaction ID. The same transaction, we got these two files. That is the reason transaction ID is same here. So dot snappy.parquet, two files got created here. Now let me go ahead and do this one. If at all, if you want to create a delta file, see here, uh, uh, here format, you're exclusively mentioning it as a Parquet. That is the reason why Parquet file it is generating. If you want to generate actually delta files, you need to mention format as delta here. That's it. See, for CSV we mentioned, right? For JSON we mentioned, right? For XML we mentioned, right? For Parquet we mentioned, right? For ORC we mentioned, right? Similar to that one, here we need to mention delta. That is one of the file format. That's it. How that files, how those files looks like, that I'm going to demonstrate in some time. So try to understand df dot write dot mode of overwrite. If the folder is there, it will try to overwrite that one. That means it is going to recreate that. So format of delta dot save of this particular path. In the same target path, actually, I'm just trying to create one folder called delta data. This is Parquet data. This is delta data. When you write the data in a delta format, how the data looks like, that's what I wanted to understand here. Currently, I don't have any other folder apart from Parquet data. Okay, now let me execute this one and see what is happening here. See, it got executed. It got executed. Now let me refresh this. Refresh, expand this one. See, target. Okay, under target volume, the Parquet data and the delta data also created now here. If I expand this one, now see what happened here. What is that you got? What is that you got? If I move this one little bit right side here, now what happened here? Come on, guys.
Parquet
Only one
file
option.
format.
So what I wanted to conclude here is, if you write the data in a delta format, backend it stores in a delta Parquet format only.
So in Parquet data, Parquet file, each row it creates one transaction. Some Parquet.
In the if you're writing plain Parquet file,
For
depending
each
on the
row.
number of partitions that it is creating, the number of files will be decided, right? That is what I told you, right?
Yeah.
So here the case is a little different in the delta case. Okay. So for each transaction, when I say transaction, indirectly I'm appending the data here, right? I'm inserting the data into to this folder, right? So it has created actually one Parquet file. Inside this Parquet file, your actual data is there. Along with that one, you try to observe one more thing here. What is this?
Log
Underscore delta log file. See here, if I expand this one, see this folder is different and this file is different. So along with this Parquet file, one more extra folder got created, that is delta log. Inside the delta log, I have one folder called staged commits. staged commits. Inside that one, I have two files actually. So 0, 0, 0, 0, 0, like that. I don't know how many zeros are there here. .crc, .json is there. What is this CRC? CRC full form is cyclic redundancy check. If something happens to the data, or if at all, if you want to travel back, we are going to use this file. Backend, it uses this file actually. Okay. We don't deal with these files mostly. Okay. Forget about this file at this point of time. Okay. The only file that we have to focus is .json. What is there inside this JSON file, Shiva? Okay. That's what we need to understand here. Okay. So if you want to, if I want to read the data from the JSON, well, how do I read that? Come on, help me. If I want to read the data from this JSON file, how do I read that?
Read dot JSON.
Spark dot read dot, right? Same
Spark dot read.
concept, right? Spark dot read, Spark dot, sorry, my bad. One second. Spark dot read dot, format of JSON dot load of that path we need to give, right? Fully qualified path. Now, how I can give that path is click on this one, and we have here copy volume file path is there, right? So just click on that one and try to paste that particular path here. Mention that one in single quotes, because our backticks also you can mention, that is also fine. Backticks are this one, anything is okay. Now let me try to read this one. So backend, it has to store the data in some data frame, right? JSON underscore df equal to, I'm just trying to mention here. If you want to display the data, you can see like this, display of JSON df. Okay, let me execute this cell. Now see what happened here. So we have two columns actually called, one is add column, second one is actually commit info, and third one is actually metadata. Okay, and fourth one is protocol, something backend, some metadata is they're trying to create. See, simply what they're trying to do here in this add, actually, what do you see here? Modification time is, see, they're trying to store the timestamp in Apache format. This is the easiest way to store the timestamps. It doesn't like take more space. Okay. See, this is the file that they're trying to add here for this one. Okay. And size is 1099 bytes. And the stats related to that file is number of records are 2. So we have actually taken 2 records only right here. Yes, the number of records are 2. And the minimum value, min values of event ID is 1. Min values of the event name is event A. Okay, min values of the event date is this one. Max values of the event ID 2. Event name is this one. Event name is this 2. Okay. So null count is currently 0. Okay. Event ID null count is 0. Event name null count is 0. Event date null count is 0. Something like that it is showing. Just by seeing that one, uh, what did you recollect? Do you really recollect something here? What is this? Have you heard about this anytime? Min values, max values, null counts.
Snowflake.
What is that?
Metadata and
Uh-huh.
metadata store something.
What metadata? Metadata is related to what?
Table.
Micro partition, right?
Micro partitions. Many.
This Spark file is quite equivalent to micro partition now. When you insert some data, actually it is creating a micro partition. I mean, the terminology is not micro partition here. That is the Snowflake terminology. These people are saying that it is storing in a like delta format. That's it. See, I told you many similarities are there between the Snowflake and Databricks. This is one among them. At each partition level, I told you in Snowflake, minimum value, maximum value, everything is maintained, right? This is what the metadata I was talking. Okay, okay. I just wanted to show you what data it actually holds inside this file. That is what my intention here. Clear?
Yes.
Okay.
What
Huh.
is the size of this file, Shiva? Parquet file?
Parquet file, 1099 something is there, right? Size 1099 bytes.
How much it allows? File.
Okay, okay. So you're asking with respect to Snowflake, right? Okay, in Snowflake, each partition size is 5 to 50 MB. Now, what is the size of this one? No, we don't have any specific size here. That depends on the amount of the data that you're writing at that point of time. Okay, currently stick to that one. I'll talk about that one a bit later.
Okay, okay.
Okay,
No,
okay.
no, the data is available in the file, right? Whatever
Yeah,
data.
correct, correct. You cannot able to read that one directly. Okay,
Okay.
so I know that
So you cannot
you're
query that, right?
you
Using the
cannot, no, you can query it, but you cannot read that file using spark.read.parquet of that
okay. Query means like
load is
how
there.
you just select star from
We can do
somewhere.
that. We can do. I'll come to that point. I'll come to
Oh,
that point. See, this is exactly behaving as a table. This delta data folder is acting as a table. You can do DML operations on top of this one. You can query it. You can do whatever you want. You play with that one like anyway. Okay. Okay. So what I
Shiva,
wanted to do is I wanted to create one more record and write that one to the delta data one more time. Okay. So how I can do that one? Let me expand this one here. Let me create a new cell here. What I wanted to do is this time I wanted to take 3 and 4. Okay. 3, 4, 3, 4. I've already taken, I think. The other one, 3, 4 are already taken. Let's say 100, 200 I'm taking here. That's fine. Oh, sorry. 100, 200. So event X, event Y, some data, some junk data I'm taking here. Okay. So once again, I'm trying to create a data frame and I wanted to write this data frame data to the same folder again. Same folder again. Okay. So where is that command? Delta data command is there right here. Let me copy the same command here. Let me come down here and try to execute the same thing and see, try to observe what is happening here. Okay, backend things we need to understand here. So instead of overwrite, I'll just try to put it as append. I just need to, I just wanted to keep appending the data to that folder. So format again, delta, save of the same path I'm trying to use here. Okay, let me execute this one. See, it got executed here. Okay, it got executed just now. Okay, it took 1 second actually time. If I expand this one, delta target volume, delta data, and see what happened here, and see what happened. What is that you observed here? What is that you observed? One more new Parquet file got created, right? Indirectly, one more new micropartition, right? Correct?
Yes.
Correct?
yes.
Now, if I expand this delta log again, what happened here? Previously, these two files were there. Now we got these two files. One CRC, one JSON. Even if you read this one JSON again, you'll get the same kind of information. Whatever we got right previously, similar kind of information we get here. See, the minimum value, maximum value, everything is add here. They're just add means they're just trying to create a new file here. So even text, the minimum value is 100, maximum also is stored somewhere here. Yeah, 200. I'll tell you why these values are captured here. You guys know, you guys very well know about why min and max values are captured here. Okay. So see, every time you try to insert some data into the delta table or delta file, this I call it as a delta table, guys. From now onwards, I call it as a delta table. Okay, I did not name this one, but I'll call it as a delta table. I'll tell you why I call it like that. Okay. So now what I wanted to tell you here is in the documentation, I told you, you have seen one point right here. What is this? Scalable metadata. What do you mean by that? What do you mean by that?
Can
As you
increase.
keep adding the, see, you add 1 billion of record to 1 trillion records here. See, backend simply what happens? It simply creates one Parquet file and one JSON and one CRC file. That's it, right? That's what they are trying to do, right? You insert 100 record, 200 record, 500 record, 1 billion record, 1 million, 1 petabyte of data also you insert. Forget about the size of the Parquet file. Currently, what it is doing? It is simply creating actually one CRC, one JSON, one Parquet file. That's it. Delta is nothing but delta log folder and one Parquet file. That's it. This is what I was. This is the explanation for the for this point. Scalable metadata. Okay, clear? Any question so far?
So if we use overwrite of the data instead of appending, then we have one bucket file or two.
Overwrite is nothing but indirectly drop and create, right? That's what I want.
Uh,
Truncate and create, right? So
okay,
I
okay,
don't want to do that. That is the reason why I just used here append. Okay. So if you want to do that overwrite, okay, you can still go ahead and do that one and see what is happening here. Okay. I am just refreshing here and test DB, test schema, target volume, delta data. See what happened here. Still, it is writing the data to the same folder. Same folder. See, currently you don't try to understand the override behavior here.
yeah.
Okay, just try to understand like when you try to insert some data into the table, what is happening. Okay.
Yeah.
So where is the files here? CRC or some?
Yeah, here we have, right?
Oh,
So
okay.
two JSON, two CRC, two JSON.
Sorry. Okay. So each transaction it is considered as a new file.
Correct. Correct. Exactly. That is what my conclusion. Insert operation is nothing but a transaction here. Your database transaction. For each transaction, whether you do insert, update, delete, merge, everything we are considering as a transaction. For each transaction, one CRC file will be created, one JSON file will be created. Uh, Parquet file depending on the operation, transaction. If it is insert, and how many records you're inserting, based on that number of Parquet files will be decided. If it is update, the behavior is little different. If it is delete, the behavior is little different. I'll talk about that one maybe tomorrow. Getting my point?
Shiva, how to identify the timestamp of file creation?
Which file creation?
This Parquet file.
Why do you want that one? I mean, I'm just asking you. Okay. Why do you want to know that? What is the use of that?
No, now we have a three files. One
Uh-huh.
is append, one is overwrite, one is something.
Uh-huh.
In
Uh-huh.
which one is append, which one is overwrite? Like
You don't need to do that. I just inserted the data to the delta table. That's it.
So I think you can see that kind of information in the JSON file. I think so.
You can see that one. You'll get that information directly here. Uh, See here, using this modification time, you'll come to know the timestamp part. But we never ever directly look into these Parquet files and when was it created, why it got created. We don't bother about that actually. It is just a back-end operation, I'm telling you.
Okay, okay.
Okay. See,
If
in the database, you do inserts, updates, deletes, and merges. That's it. How they are storing in the backend, you never worry about it, right?
yes, yes.
This
So
modification time is time only, right? So,
just a timestamp only. Yeah.
fine.
Apache
Modification time
time
is nothing but
format,
when was
right?
it created.
Oh,
The time format is Apache time.
Apache format, yeah. So let me copy this one
you can
and
convert it.
Apache converter I'll try to open. See, today's date only it will show 2025 8/10. Oh, sorry, day 8th means like it is showing in a GMT time, right? So
Yeah,
in
correct only,
GMT
right?
it is 8th date only, right? That's the reason it is showing this one. See, Wednesday, October 8th to 18 a.m. That's correct only.
Shiva,
Hmm.
like first time we second time we appended, right? So that what are the transaction records we have a particular CRC file and JSON file, right?
No,
And
CRC and JSON files are the metadata files. I'm telling you.
metadata files, and
Actual
later
data resides in your Parquet files.
partition files, yeah,
Partition files
and
are Parquet
uh,
files.
okay, files.
Mm.
And later if you want to update the data,
Mhm.
so it will take that respective transaction partition file and
Don't
update it.
ask me any question at this point of time related to update and delete. I'll talk about that one.
Okay, yeah,
Okay. I'll give you clarity about that, but don't ask me that question. I'm
okay.
focusing for now
Ah,
insert
only answer.
operations.
Oh.
Okay. Okay. I know like what you're trying to ask, but I don't want to confuse you guys by
Yeah, I got
explaining all
it.
those things at this point of time. Okay. Sorry about that.
Okay.
Okay. Mm, now, we have seen like it is uh, keep extending when you start like loading the data. Okay. Now, next feature that I wanted to focus is schema evolution and the schema enforcement. What do you mean by this one, Shiva? Schema evolution, schema enforcement. Let's say I was able to write the data right multiple times to the same folder. What I will do is I'll just try to add one new column that is event log. So far, I have only three columns: event ID, event name, event data. Now I'm just trying to add one new column called event location, and I'll just try to have event location is location underscore jet. Some dummy data I'm taking here, and I'm trying to create a data frame out of it. And I'm trying to write here the data to the same uh, Parquet folder and the Delta folder. So when you write the data to the Parquet folder, it is allowing. Okay, demo. Sorry, test DB, right? I could have changed it. That's okay. Okay, now let me execute this Parquet. See, it is allowing this. It is allowing. The Parquet is allowing Parquet data. Parquet files are plain Parquet files only. Okay, now when you try to write the same data to the Delta here and see what is happening here. See, it is throwing error. What is this error actually? You try to read that. A schema mismatch detected when writing to the Delta table. Why is it happening here? See, what I wanted to prove here is your Delta tables are actually behaving like your regular database tables. In the regular database tables, if your table has, like, say, column A, column B, column C, and but while inserting, you're mentioning column D also, will it allow? Will it allow you to insert?
No.
No, same thing here.
No.
No, same thing here. Because in the Delta table or in the Delta folder, actually, what is the schema? Previously, we have only three columns, right? What are those three columns? Event ID, event name, event date. That's it. But now we are adding one more new column called the event location. This is what we call it as a schema evolution. It is not a, like, once you define the schema, it will not allow you to add new schema. But there is an alternative way. I mean, there is a way to do that. But first, I'm trying to tell you about the schema evolution. Clear?
So here we'll consider one folder as a one table here, delta data.
Yeah, correct.
Okay.
Correct. Even in the Unity catalog also, if you are creating a table back and indirectly it is going to create a folder with that.
So now we have created only one delta data table.
Indirectly, yes, correct.
Indirectly. Okay.
Correct. So I'll come to that point. Okay, so now what see what I wanted to prove here is your this folder will exactly behave like your table in your databases. When you try to insert the data with additional column, it is not allowing us to write it. See, we are playing with the files here. Where I'm going here, you try to understand the theory part here. So where I'm going, we are playing with the Parquet files, how the Parquet files are slowly like acting as a tables here. That's what we need to understand. That is the beauty with the Delta Lake actually. We know that Parquet files are, it's a just file format, that's it. But how the people converted it like a database here, see? Okay. So now, if at all, if you want to manage that actually, we have an option, guys. Don't worry about that one. That is merge schema equal to true. We can merge actually this one, the schema, additional column. Okay. And before that one, Shiva, you're saying that this folder is a table, right? How do you read the data from this folder? How do you read? I wanted to know what data is there inside that one. You guys know the format is Delta, right? Just try to give that folder name here. That's it. Volume instead of demo DB, I'll just try to mention it as a test DB here and see that read the data here from this one and see what is happening here. This is the data we have inserted. We have overwritten, right? That is the reason why truncate and load, right? We have overwritten the data, right? That is the reason it is showing only 100 and 200 here. If you have written append, then it could have shown all 4 records. Okay.
How long these CRC JSON files available? 0, and 01.
I'll talk about that one also.
Okay.
I'll create an account tomorrow, the Azure account. Actually, for every 6 ORC JSON files, one consolidated file will be created actually in the backend. Once the consolidated file is created, then these files will be deleted in the backend.
Just
That
like
that Delta will manage. Databricks will manage in the backend. That we don't need to worry. We don't need to manage anything here. Because see, when you do select star from this one, okay, so how we can read the data, so how you're reading the data from the table in the same way, select star from, how you read the data from the table, actually select star from table, right? This is nothing but a table here, delta dot that path I'm giving here. See, once you read the data, see how it is behaving here. Okay, test DB, right? That is the reason why it is failing. Control enter is a keyboard shortcut to read that, execute this cell. See? We're able to see the 100 to 100 here.
by default, it's showing a display output.
Yeah, exactly.
See, delta dot means it is a file format.
File format. Even if at all, if you want to read the CSV file, CSV dot, that is
CSV
CSV
dot.
path also we can mention. Parquet also, parquet dot, that parquet path we can mention. For delta, delta dot, that path we can mention. I mean, it is just a notation here, that's it.
Mhm. So we can query this like right target schema and schema name DB and the delta. Just we consider that is a table, right? With
We can
here,
consider this as a table.
no, without path.
We can create a logical table on top of that and we can use that logical table name here. I'll tell you that one. Once we slowly like start
Okay, okay.
understanding that one, we'll try to do that. See, my point is here how that Unity catalog is evolved. That's what I wanted to tell you here.
Mhm.
Okay, so how this Delta Lake came into the market and changed everything here. That's what I wanted to tell you. Okay. So we can read the files actually in this format. Indirectly, this is acting as a table here. This folder, entire folder. Okay. What is that folder called? Delta data folder. Indirectly, it is acting as a table, and we can read with the help of this command. Okay. Merge schema option is there, right? Yeah. So merge schema option with the help of merge schema option, we can add the additional schemas as well. Okay. So let me execute. This option also we used many times in the real time, guys. Okay. Now let me change it actually. Test a schema. Execute this. See, it got executed. Now, if I want to do select star from this table, now see what is happening here. 4 columns you'll get. Now see. For first 2 records, actually, the data is null for this column because even only in the third column, actually, we have that. See, indirectly, we are extending a column to the table here. Alter table, table name, add column you do right in databases. Same thing we are doing here indirectly. Nothing new. That we can achieve with the help of option called merge schema equal to true. Okay, so this is nothing but schema evaluation and the schema enforcement. This is what we call it as a schema enforcement. If you want to enforce the schema, that is the additional column here, then you can go ahead and use the merge schema. Okay, yeah. We can discuss the rest of the things tomorrow. Everything I'll try to discuss all these features. Don't worry.
So where you added the new column here, the merge
This is the
schema.
one, right?
Uh,
This is the one, right? Event location. Event location is the new column. Previously, we have only event ID, event name, event date only, right? Now I've added additional column called in the evolved schema. Actually, I just added that new column. So I'll show you if you want. Yeah, see, previously we have only event ID, event name, event date only.
okay.
Now I'm just trying to combine the PySpark and SQL here. Mix. That is what you're going to do from now onwards. Yeah, so that's all from my end. Any questions?
Shiva, can we consider this slash volume slash db slash schema is a fully qualified path, right?
Yeah, correct. Fully qualified path only.
In real time, how we can create
Volumes we create actually on top of that S3 location path or the on top of your branch 2, sorry, not branch 2, this ADLS Gen 2 is there, right? On top of that one, we create this logical path. So we don't refer directly ABFSS colon slash slash that container name, that storage account name. We don't, every time we don't refer that. It's a volume is just a logical name on top of your storage.
Okay.
Instead of referring to S3 colon and all, see, in this Databricks free trial account, we don't know whether they tied up with the AWS people or Azure people. If they could have tied up with the AWS people, they never ever say that, hey, when you try to upload some data, we'll try to store the data in so on so S3 bucket. See, that is logical backend path, right? That they will take care, right? On top of that one, they're just giving a logical name here. Hey, you create a volume. Volume is nothing but a drive or something like that. Okay. You create folders, subfolders, upload files, do whatever you want on top of it.
Okay.
I don't expose that S3 path to you. Clear?
Yes, sir.
Okay, let me